Hello, this is a new video, and the title of the uh, manuscript that I want to share is the zebrafish as an animal model for drug discovery in Parkinson's and other movement disorder, and it's a systematic review study. So zebrafish is sort of fish. You can check its pictures on Google. Movement disorders can be primarily divided into hypokinetic and hyperkinetic. Most of the hypokinetic syndromes are associated with the neurodegenerative disorders, Parkinson's. By contrast, hyperkinetic syndromes encompass a broader array of disease, including dystonia, tremor, or Huntington disease. The discovery of effective therapies for these disorders has been challenging and has also involved the development and characterization of accurate animal models for screening of new drugs. Zebrafish constitutes an alternative vertebrate model for the study of movement disorders. The neuronal circuitries involved in movement in zebrafish are well characterized, and most of the associated molecular mechanisms are highly conserved. Particularly, zebrafish models of Parkinson's disease have contributed to a better understanding of the role of several genes implicated in the disease. Furthermore, zebrafish is a vertebrate model particularly suited for large-scale drug screenings. The relatively small size of zebrafish, optical transparency, and life cycle are key characteristics that facilitate the study of multiple compounds at the same time, and several transgenic, knockdown, and mutant zebrafish lines have been generated and characterized. Therefore, it's central to critically analyze. So this is it's not a short abstract indeed. The majority of the studies were focused in the characterization of zebrafish model of Parkinson's disease. Overall, the zebrafish models included display conserved biochemical and neurobehavioral features of the phenomenology in humans. Nevertheless, in light of what is known for all animal models available, the use of zebrafish as a model for drug discovery requires further optimization. Future technological developments, alongside with a deeper understanding of the molecular basis of these disorders, should enable the development of novel zebrafish lines that can prove useful for drug discovery for movement disorders. So, it's interesting, and let's look at the introduction and the figures as representative images of zebrafish at embryonic as a model for translational research. The section of monoaminergic system in zebrafish. We can see this, and methods were introduced, and the other induced models, paraquat induced models, rotenone induced models, other neurotoxic agents. So this is wow, this is very, they spent quite time on it. This review underscores the strengths and limitations of zebrafish models of movement disorders developed to date. Importantly, it raises awareness that zebrafish can mimic the phenomenology of different movement disorders, but needs further characterizations. To date, there are a substantial number of studies reporting the use of zebrafish as a model for Parkinson's disease. However, for other movement disorders, this number is still limited. Considering the pathological hallmarks, motor phenotypes, and responsiveness to pharmacotherapies from the 7 movement disorders reviewed here, zebrafish models have only been fully characterized in the context of PD. Notwithstanding the use of zebrafish to model human disorders dates back to the beginning of the 21st century, which compare with the 5 years use of rodent models is at embryonic stage. This difference of half a century may explain the skepticism that still exists about the use of zebrafish as an animal model of human diseases. The number of studies reporting the use of zebrafish as an animal model is growing, and therefore the analysis of the pros and cons of the use of this model for drug discovery is important. So it is clear and very good article, and if you are more interested in, you can find it and read it carefully. And that's all I want to say. Thanks for watching this video, and see you. Bye bye.